Welcome to another video from Roland Mösel, founder of Planetary Engineering Group Earth. Disruption at houses. Before we look at disruption at houses, let's look back at the big disruption at cars. Tesla was only founded in June 2003, and 18 years later, the value of this company is bigger than the 10 next following big car companies together. Let's look what was in year 2003 an electric car. The Peugeot 106 electric. It was only possible to buy it used because Peugeot made a small series of these cars 1991 and finished production. It was only an experiment, and fans of electric cars purchased used electric 106 cars, and one of these was here. It has 11 kilowatt hours of battery, 11 kilowatt electric engine, peak performance 22 kilowatt. And when you drive energy saving 80 kilometer range. But how to drive not energy saving when you have an 11 kilowatt engine in this car? So it's a joke. And in February 2005, I made a report about this car. And with this report about this electric car, I was with the German word for electric car, German Elektroauto, for several years in the number 1 position at the Google search for Elektroauto. In such a terrible shape was at this time the electric car industry. Unbelievable, terrible. But I tell you something. The house industry is in the same as the electric car industry was 2003. It's a disaster what they say, oh, this is a house and it's very expensive because it's a very good house. It's like, oh, look at the Peugeot 106 electric. It's such a great car. But here we have a question. What is a good house? And we try to find an answer with an old spell if everybody did it. So let's imagine everybody would have a house like this, and would it be good or bad for mankind? But before everybody did that, there are two obstacles in front of it. Everybody should want it, and everybody should also be able to do it. And the effect of all this should be a maximum positive impact on the future of humanity. Let's try to evaluate houses. First, we start with all the construction material, all the technique in the house, and we evaluate how much kilowatt hours of electric power is used to make all this material until the house is finished. All in electric power, this is a universal exchange, electric power for all. But there are also CO2 emissions from creating these materials. And for this, we say 8 kilowatt hour for 1 kilo CO2 emission. This is because of the following. We need to filter out the CO2 from the atmosphere, and we have to split it again in oxygen and carbon. And this needs about 6 kilowatt hours per kilo CO2. But we have also to make all the equipment to do this. And for this, we say 8 kilowatt hours per kilo CO2 emission. For example, the production of steel. With the carbon reduction, we emit 1.75 kilo of CO2 per kilo of iron. And so 1 kilo iron has, only because of this reduction, 14 kilowatt hours of electric power to be calculated in this balance for a house. As soon as the reduction of steel is done with hydrogen, this will improve. We consider all these factors: electricity for the production of building materials and 8 kilowatt hours per kilo CO2 emission. Domestic electricity for 30 years, we make the balance always for 30 years. Domestic hot water or production, room heating and room cooling. Since the climate changes, since it becomes warmer and warmer, also cooling is an important thing, even in Germany, what is far north, but it becomes also here warmer. Then mobility, to charge the electric cars of the inhabitants of the house. And then we have an exchange of 6-to-1 for electricity, because it's a big effort to store electricity from the summer for the winter. We know only one method what is realistic, and this is power to methane. Store the methane in underground storage. These underground storage are already in Germany, they have 25 cubic kilometers of it, and combined cycle power plants. And at the end, we have about 27% of the invested in the electricity, but we have also to calculate to create all this infrastructure to do this. And so we say 6-to-1. When you take 1 kilowatt hours of electricity in winter, we put in the balance 6 kilowatt hours, 6-to-1. Okay. And here we have the application factor. How big is the surplus electricity production of the house? We have all this in the balance, even this 8 kilowatt hours per kilo CO2 emission at creating the construction materials, even this 6-to-1 exchange rate for delivering electricity to the grid and consuming electricity from the grid. And after all these heavy factors in the balancing, we have a surplus of energy, and now we calculate how many houses in 30 years we could make with the surplus of energy. This is sure different at different places. When you are more close to the equator, there is less difference between summer and winter, and so it's no problem with this 6-to-1 balance factor. But when you go as far north as to Oslo in Norway, this becomes very dramatic, because even with a very huge photovoltaic, you can produce in December and January nearly nothing. You have to consume much from the grid, and here is the 6-to-1 exchange factor very dramatic. But even in Berlin, we have a positive replication factor. So, what means a replication factor from 3? This means that the surplus electricity of the house can produce another house after 10 years. Now there are 2 houses, and after 20 years there are 4 houses, and after 30 years there are 8 houses. Whatever you could do with excess electricity, it is here expressed in how many houses of the same type could be produced with it. It's because of a special German word, new invented German word, Bauscham. This means you should be ashamed for making a new house. Remain in your old house, make a little bit renovation, a little bit more thermal insulation, that's all. you have to remain in your old house. You should be ashamed to make a new house. Completely mad? Yes, it's completely mad, but in Germany, even complete mad thoughts can make it. I found this in the demands from some of environment groups. I called them and they told me, yes, Bauschaum is something great. We should not make new buildings. Think on it. 1939 started Germany a revenge party for the lost First World War. So you see, you should be concerned about mad German ideas. They make it complete mad. So the word replication factor should be the total destruction of Bauschaum. Next, the house should work at any inhabitable place on Earth. It should work the same in Salzburg and the Sahara Desert. And you would think, oh, why? A house remains on the same place. But on the same place, the climate could change. For example, we have here on the left side Hamburg, a thermal balance of the house, how much energy for heating is used in each month. And we have on the right side Prince George. Prince George is on the same latitude like Hamburg. It's on the west coast of Canada, and the climate there is much different. You see, we use much more heat energy in Prince George compared to Hamburg. But what happens when the Gulf Stream goes down? Then it could happen that Hamburg and Prince George would have similar climate. It would be much colder in Hamburg. The record cold in Prince George is 1950 minus 50 degrees Celsius, something what never happens in Hamburg as long as the Gulf Stream works. And there are also dramatic differences. Here in Middle Europe, you can dig a water pipe 80 centimeters down in earth and it will not freeze in the winter. 80 centimeters is enough. But in Prince George, you have to dig a water pipe nearly 2 meters deep in the earth that it does not freeze in winter. Earth is a big difference. Danger of flooding. Stop soil sealing. Stop concreting everything. There are big campaigns in Austria and Germany about this theme, and there is necessary to give an answer on this. But what if a house can absorb more rainwater than a grassland? Then we would have negative soil sealing. We increase the amount of water what can be absorbed instead of decreasing it, and so we have put down this argument. All agricultural land is needed for food production. No more conversion to building land. These people think forever this land will produce food, as much food as today. There are already studies because of the climate change. The production of this land will go down, much less food from the same land, much more effort to create only a smaller yield, but they don't think on it. They only say no more conversion to building land. And supply and demand determines the price. And when you make an artificial shortage of the supply, the prices go up and up. And this is the catastrophe of Building land is more and more expensive and nearly nobody can afford it, maybe only the richest 5% of population. Nobody else is rich enough to make a new house because the ground is so expensive. But what if more food is produced on a 500 square meter building plot in a 50 square meter vertical gardening aeroponic system? If this happens, this argument is destroyed. Due to increasingly heavy rainfall, more and more areas have to be classified as food-prone and construction has to be banned. Oh, you thought maybe this is a good construction land and then suddenly flood risk, construction ban. And here also this applies. Supply and demand determines the price, and when you make a shortage in the supply, the price goes up. But what if floatable homes are available? When the additional price for the ability of swimming is far less than the higher price of construction land with no flood risk, then this argument would be destroyed. Due to extreme drought, catastrophic wildfires are becoming more common. Fire insurance is no longer offered in areas or at risk. So we have the situations that in some areas are real construction bans, and in other areas we have maybe the situation that you can make a house, but no fire insurance will make a fire insurance for the house, or you have to pay so much for the fire insurance that it's impossible to make a building there. But what if houses can defend against wildfires? The premium for the fire defense is only a fraction of the savings from building land. In this case, you could build a house in a fire area, in a high danger area, and maybe you have to make a firewater pond. And this firewater pond looks like a swimming pool. It can be used like a swimming pool, but it is a firewater pond. Then we have to discuss about mentality. There is a millionaire mentality and there is a billionaire mentality. The millionaire thinks on high-priced exclusive products for rich people. A typical story could be, I made my first million with 10 furnishings for villas. All super exclusive and top quality. Of course, you have to have the best connections to the scene of the rich people. And there is a billionaire mentality. Cheap products for everyone. And a typical story of a billionaire could be, I made my first billion with 1 million home furnishings. The low price with good quality got around, customers stormed my stores. The competition was desperate. We want for our project people with billionaire mentality. We want to create a cheap product for everybody with very high performance and quality. This is our target. We don't want to make an exclusive high-priced product which can be purchased from some rich people, and then these rich people tell, look at my super house. You can't afford it. I hate your poorness. It's terrible that you are so poor. This is not our target. We want to make a product for everybody with very high quality and very affordable price. Our mission statement: planet renovation, back to 350 ppm CO2. We contribute house by house. This was another video from Roland Mösel, founder of Planetary Engineering Group Earth, and as always, like, comment, subscribe and hit the bell to be notified when I make my next video.